Hello guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at the concept of oxidation and reduction. And we're going to start with oxidation. The term oxidation was first of all used to refer to reactions in which oxygen was added to an element or a compound. And the earliest example of this is combustion. However, the concept and definition of oxidation has included other reactions in which oxygen is not added to a substance. So what we're going to do now is to look at the various definitions of oxidation, and then before we go to reduction. Oxidation can be defined in several ways. The first way by which it can be defined is as the addition of oxygen to a substance. The two examples we have here are as follows. The first one shows the reaction between magnesium and oxygen to give magnesium oxide. In this particular example, magnesium is being oxidized to magnesium oxide. In the second example, sodium sulfide is being oxidized by hydrogen peroxide to give sodium sulfate. Because an oxygen is added from hydrogen peroxide to sodium sulfide to form sodium sulfate. Another definition of oxidation is that it is the removal of hydrogen from a substance. In the example we have here, hydrogen sulfide reacts with chlorine to give hydrogen chloride and sulfur. What happens in this particular reaction is that hydrogen sulfide, by reacting with chlorine, is being oxidized to sulfur. The third definition of oxidation is the addition of an electronegative element to a substance. It is important for us to recall that oxygen is a highly electronegative element. As a matter of fact, oxygen is the second most electronegative element in the periodic table. So, if the addition of oxygen to a substance is oxidation, and oxygen is electronegative, the addition of other electronegative elements to a substance is also oxidation. In the example here, chlorine reacts with tin 2 chloride to give us tin 4 chloride. Chlorine is an electronegative element just like oxygen. So, the addition of chlorine to tin 2 chloride to give us tin 4 chloride is also an example of oxidation. And the final one we're looking at is that it is the removal of an electropositive element from a substance. Hydrogen is electropositive. And if the removal of hydrogen from a substance counts as oxidation, it also means that the removal of other electropositive elements from a substance also is oxidation. In the example here, potassium iodide reacts with chlorine to give potassium chloride and iodine. In this reaction, potassium, which is an electropositive element, is removed from potassium iodide, leaving iodine. So what this means is that potassium iodide is being oxidized to iodine. Reduction is the reverse of oxidation. And the definitions for reduction are as follows. Reduction can be defined as the removal of oxygen from a substance. In the example here, copper 2 oxide reacts with coke to form copper and carbon 2 oxide. So what happens here is that copper 2 oxide is being reduced by removal of oxygen to copper. The second definition is the addition of hydrogen. So reduction can also be defined as the addition of hydrogen to a substance. In the example here, hydrogen is added to a thing to give ethane. So a thing is undergoing reduction by the addition of hydrogen to it to form ethane. The third example is the removal of an electronegative element from a substance. Oxygen is an electronegative element. If the removal of oxygen, which is electronegative, counts as reduction, then it means that the removal of other electronegative elements is also reduction. In this reaction, iron 3 chloride reacts with hydrogen sulfide to give iron 2 chloride and hydrogen chloride as well as sulfur. So, what happens here is that a chlorine atom is removed from iron 3 chloride. So what this means is that iron 3 chloride is being reduced to iron 2 chloride. And the fourth one is the addition of an electropositive element to a substance. One of the definitions of reduction is the addition of hydrogen. Hydrogen is electropositive. So, if the addition of hydrogen, which is electropositive, to a substance counts as reduction, it also means that the addition of any other electropositive elements to a substance is also reduction. In the example here, mercury 2 chloride reacts with mercury to give mercury 1 chloride. So what happens is that mercury, which is an electropositive element, is added to mercury 2 chloride. And this reduces mercury 2 chloride to mercury 1 chloride. Having looked at this, it is now important for us to consider the modern definition of oxidation and reduction. The modern definition of oxidation and reduction involves electron loss and electron gain. So according to the modern definition of oxidation and reduction, oxidation involves the loss of electrons, whereas reduction involves electron gain. So let us use a hypothetical element to illustrate this. The element X gains an electron and gives us a negatively charged A. If this element X loses an electron, it gives us a positively charged A. So in the first illustrative equation here, the element X is reduced because it gains an electron. It is reduced to the anion. In the second illustration here, the element X is oxidized to its cation. So this is reduction because it involves gaining of electrons, and this here is oxidation because it involves loss of electrons. It is also important to understand that any substance that is undergoing oxidation is a reducing agent, and any substance that is undergoing reduction is an oxidizing agent. So here, magnesium is undergoing oxidation to form magnesium oxide. So here, magnesium is a reducing agent. Take this example here. Copper 2 oxide here is being reduced to copper. Copper 2 oxide that is being reduced is an oxidizing agent. So please do not forget that any substance undergoing oxidation is a reducing agent. And any substance undergoing reduction is an oxidizing agent. So I want to believe that the definitions of oxidation reduction is clear. Thank you very much for watching and see you in the next